Hello. Wow. Nice. All right, Ciro. You have to speak loudly.
Yes. All right. Hello. Hi, everyone. Welcome. We're also live on YouTube, I hope. Tadej is now the director, as you can see. But yeah, welcome to this game jam. This is the first, as far as I know, external coherence game jam that Coherence organizes. But actually, I mean, who of you knows coherence? And a little bit, okay. So about coherence, one interesting thing that I found and that really pushed me to actually join the team is that the company has a very, and as a culture, let's say, rooted in game jams. Like they do a game jam every release, and then they try the tech themselves, and they, hunt down bugs, but also to see like different game styles. The video that you've been seeing so far was basically one of the older game jam videos. So you can see a few games that the coherence team made a while ago. And you can see that they really change, they really move between different genres, which I think is cool. So we're going to continue that tradition. And this is the first time we do it with external people, which I think is pretty cool. And it's also pretty scary. And I can tell you that the team is scared. Like Sandeep is shaking uncontrollably, but he has a, has a strong sense of control, actually. So yeah, how do you move forward? Yeah, a multiplayer game jam, crazy, right? Yes, but that's the bet, right? That's what we want to try and see if we can, if you can make something this weekend that is actually multiplayer, and that's the challenge. But we think that coherence can help with that. I think it's going to be fun. We plan to obviously jam all weekend, and then in the end, we plan to play each other games. You will see coherence as a way to export to WebGL as well very easily. And you can share the link, and it will be very fun to play all together, not only here, but we can maybe share the link online and just bring people in. You can bring friends, or we can figure out if you want to bring somebody external. What else to say for now? I just wanted to show you the schedule to start with. So I think it was on the event website. It's very simple. It's a classic game jam format. We start today. We end at 2 p.m. on Sunday, local time. Because, by the way, there's also people joining remotely. They are somewhere in the Netherlands, South Africa. We have USA, and I don't remember where else. And but yeah, all these times are local, of course. So yeah, we finish at 2 on Sunday. The only, let's say, major bit that we have in between is this ideas check-in tomorrow morning. It's not mandatory. It's just if you want. We're going to do it here. We're going to stream it. If you're here, we would love to hear what you're working on. You don't need to show the actual game. You can also just talk about it. It's just nice to, like bounce ideas around and see what the others are doing. Maybe they give you a better idea for the Saturday. If you do have something, we also have a way to stream that to the actual live stream. So if you want to show it, we have a way to do that. Just ask us. And that's pretty much it. And then at 2 p.m., we stop jamming. You upload the games on itch or whatever, like this WebGL link that you can make with directly on Coherence. And then at 3, we take a look at the games. We play each other games, we show them here on the screen, and we will have like a little voting round to elect like the best one. That's pretty much it, very simple. But what is coherence? And this is where Tadej comes in, and he gives us a demo.
All right.
So Tadej, I'm going to leave the floor to you. He's going to show a bit of the basics and how to make like a 101, let's say, coherence demo.
All right.
You can use it, with questions at the end.
Yeah, we're going to do this together a little bit. I've only practiced this once, and I'm sure that things are going to go wrong. And then we can see how we fix them together. Yeah, like this, for instance. All right. We don't need this, but we will. So first of all, to give you a short introduction about why we started Coherence and what it is that we're trying to achieve. So we're all game developers, more or less, at Coherence, and we've all thought about making multiplayer games or made multiplayer games, and we've used other tools. And I mean, it's not really been possible to do a game jam before with multiplayer. Maybe if you're very experienced, but we really want to change that. In addition to this, we started building an engine that can do more things than other engines can do. Like we got very intrigued. A lot of us really like MMO games, for instance. How do you make an MMO game? What kind of architecture do you need to use? And many of these games, they require a very special type of architecture when thinking about them. And we want to make it all of this very simple and very easy to switch between. So, for instance, a lot of games, when you run them online, people get worried about, oh, I need to run my servers in the cloud. It's like crazy expensive and stuff like that. So we want to give people flexibility when it comes to that. So you can choose what kind of authority model you have. Are you doing like server-side simulation, or are you just doing a game jam and you can do client-side simulation and it's no problem, right? Today I want to give you an overview of how you make a single-player game multiplayer with Coherence. Like just a simple overview with some of the features that you might need this weekend. And for this, I prepared, I cheated a little bit. I imported the Coherence package before we started. And here I have, I'll just show you what it is. It's like a simple Fox game. You're running around and jumping around and going in the water, and there's an animation system, and then you're swimming and so forth. But this is single player. There's nothing coherence in this scene right now. Like the way I have this set up is there's this game script that I wrote that has a reference to a prefab called Fox single player. And this prefab has a bunch of scripts. This is an asset I bought in the Unity asset store. So it has like an animator, it has a rigid body, it has an input script, it has an animal script, which takes care of some of the logic behind how the animal moves, stats, health, and stuff like that. And that's it. Now, without doing any coding, at first, we're going to make this multiplayer. So first of all, how did I actually install Coherence? And you'll find these instructions in the documentation. Oops. I mean, it's very simple. You have this in your project settings. I keep docking this to the wrong place. You have this package manager section here, and you add our registry where our package lives. Coherence, registry.npm.js.org, and then the scope is io.coherence.org. And once you do this, the package will actually appear here under in the package manager. And then you just see the version we'll be jamming with is version 0.9.2, which is the latest version that is public. We're working on 0.10. It's done practically, but we didn't want to take any unnecessary risks this weekend with it. And now let's look at our project. Let's see, okay, we have this scene. We have that prefab that I mentioned. And when I install Coherence, I get this Coherence menu up here. And there's a bunch of things, and we don't have to go into incredible detail with any of them. But I'm going to give you an overview. And later on, we're going to be here, and we can talk about specifics. And our Discord channel that Pat and Ciro can share with you later. We can all weekend, and even later you can ask any questions you have, and we can come and help you. But there's a thing we have here that's called the Coherence Hub. And the Coherence Hub is where you configure your game, and you make sure it can run both online, offline, and so forth. I'm going to dock it over here. And here I can see, okay, there's a bunch of tabs here that maybe I don't know what they mean. But if we go and read them, so we have overview, which is the general overview of what the project is. We have cloud. So during this game jam, we can actually upload our builds into our Coherence accounts online and share the builds with other people on the internet. We have a game object set up. We have a scene setup. And here in the scene setup, I can see in the overview, it's telling me I have no coherence monobridge in the scene, and I have no live query in the scene. And let's open the tab to do that. So I'll just go and create a network manager. This is the coherence monobridge. I click it, and I get this. So the same thing I could do from the menu and just go scene setup and create network manager, right? This is the script I have in the scene that takes care of the synchronization of the entities and game objects and so forth. And then we add something called coherence live query. And a live query is basically my area of interest, like what is the area within which on my client I want to get updates from other entities. And if I look at the default live query setting, it has a radius of 0, which means I'm interested in everything. And that's what we are in this first example. And then the next thing I can do here in this basically tutorial, scene tutorial, is I add a sample UI. So I'm going to click this, and I get a sample UI in my scene. I can see it here in the game view. Oh, why can't I? Okay. Okay, low aspect ratios cannot be disabled for some reason. And I have this UI here, and this UI is a sample UI that you can use, you cannot use, but I think for a game jam, it's nice to use a sample UI, right? Let's see, if I go to my inspector, the UI has 2 modes here. One is a worlds mode, and one is a rooms mode. So with Coherence, you can build games that are world-based, which means I can have a living world that never shuts down. So think of it as a server that's always on. I have persistence. I can put persistence on things, and when I do changes to these things, even when I'm not there, they're still going to remain on the server. And when people come back, they can still see them and stuff like that. But for this simple example, we're going to use a room-based scenario where I'm basically starting the game, I'm creating a room and inviting other people to join it by its name, right? So we've set up our scene. There's nothing else we need to do. And now we have to look at the coherent single player prefab. And yeah, all these scripts that I talked about before, all we need to do is add one component, which is called coherence sync. Coherence sync. And I add it to my prefab. And I see there's a bunch of settings here that I don't necessarily all need to understand at this moment. We can see there's many ways to load this. The first thing that I did with this prefab, I put it in the resource folder, because this is the easiest way to hot load it during a game session, right? And I'm just going to simulate it client side for this example. I'm going to say it's going to be session based. So it's my character, right? So when I disconnect, it should disappear. It shouldn't stay there. There's some uniqueness settings, there's some authority transfer, but we don't have to worry about that right now. And now, of course, I put this on, and this means if I now start it and I instantiate, the Fox is going to be there. But there's no behavior yet. We don't know what fields in the Fox we want to synchronize yet. So for this, we have a very handy configuration window. If I click configure here, I now get access to all the public stuff on my Fox. So you can see you have a transform, you have an animator, you have a rigid body, like all these fields. And I know already, like for my Fox, I'm interested in the position, which is on by default. I'm interested in the rotation. And of course, these things are going to be synchronized over the network and interpolated. I can do all kinds of settings with interpolation also, which we can go into later. But they're basically advanced settings that you don't need to worry about at first. And now with this, I'm already going to see the Fox moving around in the network, but it's not going to animate yet. So it's just going to be like a statically moving Fox. But then we have this access to the animator state machine here. And all the states of the animator, I can just select which ones I want. And we have a handy button here that selects all animation parameters. So if you want to synchronize all of them, boom, they're selected. So this, if I built this now, I would have two Foxes running around with animator controllers reflecting as they should. And I'm done. But there's another thing. So imagine you are on client 1, you spawn your Fox, and somebody else is on client 2, and they see your Fox. And the Fox has a rigid body, the Fox has an input controller. And if I didn't do something more, what would happen is that when I press, use my keyboard on client 2, I will be trying to control that Fox as well, which will clash. So what we have here is this components section, where I can say, select what happens to components on non-authoritative game objects. So that means the one that is not me, what do I want that prefab to have turned on? So I can say, okay, the animator, yeah, I need it because it's gonna change the animator parameters, and then I'm gonna see it reflected and the Fox will be running. Rigid body, maybe not so much. I wanna set it as kinematic, which means it's unaffected by the environmental physics. There's no gravity effect on it and stuff like that. Component selector, it's an editor script, I don't care. Input, yes, I wanna disable it. So we automatically detect what it is that this script do and give you some options, right? And of course, you can do a lot of this manually with Unity events later as well, but this just to show that how easy the first step can be. So the animal script, I also don't need it. I just want basically the animator and the position rotation, right? Stats, I don't know, probably not. Damageable, I can, yeah. Event listener, I can leave. Okay? So we've basically configured this prefab of ours. And now if I go back to the inspector, I can save. One thing I wanna say is that we want to often, when we make changes in the configuration window, it is basically changing how the definition of what data is going to be synchronized across the network. And coherence internally keeps this information in a thing called a schema file. And the schema file is exchanged between the server and the client. And based on the schema file, if you want optimized C# code, we can generate code for you. So it's just like super optimized code. And what I do in the hub here to make sure that this code is generated, I just go and bake. So it's like with lighting, with coherence also, you occasionally will want to bake. And this is now generated, C# files, recompiled, and everything. So let's see what happens if I'm gonna log out in Coherence Cloud. I'm gonna log out from my project, and I'm gonna go sign up and log in. And I'm also gonna log out here so you can see it from scratch. So I'm gonna go sign up, log in again. I go to the Coherence website, I log in, and now it's connected me to my Coherence account, which I just went to Coherence.io, I created a free account, and that's all you need to do. And now I have in my Coherence account here, dashboard, I have many projects because I've been working on this a little bit. And so one of them is an organization called Demos Tadej, and I already set up a new project. You can easily set up as many projects as you want. And I have this Foxes project here. And in Foxes, I've set up some things, but nothing that you really need to do. One thing that I do like to do is enable build sharing. But otherwise, you just need to have that project available. And then I go here. I have all these organizations available here. I go demos Tadej and Foxes. And here we are. You will see that you have a certain number of credits, and everybody gets like 20,000 credits every month for free. They reset. But if during, if you end up making a crazy game that needs a lot of credits, just let us know. We have a button that we can press to just give you more. And what I'm going to do, I already baked, and now I want to make sure that the cloud version of the game has this new schema also. So I just go cloud and upload to Coherence Cloud. Boom, it's there. And also, I can start a local server that I'll connect to. So if I go to, let's see, Coherence Cloud servers, I just start a local room server. And now when I play my build, you will see that I get, not only do I get a local server here, I also get the EU and US regions for the global server because I did the uploading thing. And let's connect to the local one. I just go new room, I will create it. And here you can see today's room, and I join. So now if somebody else joined, they will be able to see me here. And let's try this actually, if it worked. Let's go and build, Mac build. Yeah, builds folder, boom, replace, yes. We have this Mac build, and I'm gonna do run it. This is an executable for those of you who are not using Macs. Let's actually just open two of these. All right. I can just use the EU server or local server, doesn't matter. Okay, EU, hello will be the name of the room. I connect to it. I refresh here. I can see hello. And I have 2 foxes running around. So that's all I needed to do to make that happen. And now?
I think you deserve an applause, but not for coherence, for your bravery.
All right. Thank you. So we've made it this far. We've learned how to, without any coding, make sure that these prefabs can synchronize over the network. But let's try something else. So coherence is not like this, toy that you just use without coding. This is just, to be able to really prototype quickly. We wanted to make sure that you don't need to actually dig into the code to do all this stuff. But now I'm going to show something else. So let's look at our resources folder. What else is hiding there that I've set up? So one of the things is a cube, a physics-based cube. It's a normal cube, nothing special about it. There's a mesh renderer, box collider, rigid body, like on every cube, right? Let's add a coherence sync to this one, so we're able to see it on the network. Yeah, like this. We're gonna go, okay, resources, cube. We're gonna go configure. We want rotation as well. When it appears over the network, we want the rigid body to be kinematic. That's all we care about. And yeah, what else do we care about? Nothing. And then we also have the ability to bake, the thing I went to the hub and baked, I can do it from here. And it's notifying me that I should. And now the schema has changed. I've added something else, right? And so I have baked. I will also go to Coherence Cloud and make sure the cloud has this information. And I will also make a new build. Let's go build. Luckily, this is fast with this project. And I have not added this cube anywhere in the scene now. You'll notice that. But I'll open this client. And the editor. And with the client, let the client create a cube room. Connect to it. Oh, nice. Okay, this is nothing. Refresh. Oh, the local ones. Yeah. Okay, cube room. I join. Like still, I have this, and I have the editor, right? And now in the editor, I go to scene view. I'll zoom out a bit, zoom in a bit, and I'm bringing the cube in the editor inside of the environment. So it's basically we have everything is super automated when it comes to spawning and stuff. So you could even like develop like this in a way if you made sure about some things. Now we're going to look at another thing. So if I'm working in a client-side simulated environment, so on the left side, I have a fox and a cube, and they're both simulated on the left side. And on the right side, I'm getting just their positions reflected through the network. But what if I want to, from the right side, affect what happens with the cube? How do I do that? For that, we need network commands. So for that, we're going to write a new script together now to see how that works. So let's go create a C# script, and let's call it cube behavior, right? And we're going to open it up. And let's call it public void jump. We're going to be super messy now with the code. Don't worry about performance right now. But jump, how can I do jump of a cube? What can I do? How can I make the cube jump? What? Ooh, yes. Good one. And I do at force, I go up. And when I was testing, what was the number? Was it 1,000? Was it 800? 1,300 maybe. Maybe it will jump like crazy. Let's see. Maybe we make it heavier if that happens. And then in order for me to be able to test that this works, I'll do here input dot get key down, key code X. All right. And I'll just call jump. So if we run this locally now, let's create and join. And I go, oh, I need to bring the cube in first. Let's do it like this. And then I go X. Oh, you know what? I forgot to put the script on the cube. So I go cube. Now we can do it again. Now we have these rooms already. I can put the cube in the scene, press X, and it jumps. Oh, perfect height, right? But now, like, I can jump. I can press X and make the cube jump. And one thing we also forgot to do is the cube actually on the unauthoritative side should disable the cube script, because I have no business trying to affect the other person's height and rigid body situation, especially when the rigid body is kinematic. So, and I'm not authoritative over it. But how do I actually do that? How do I see a cube that's not simulated on my side and make it jump now? So for that, we can use networked methods. So when I go, let's go from scratch. We look at the cube prefab. We look at this. We go configure. And then we did variables before. we did components before, but now we're doing the methods. And here I have all these methods, that make no sense for me to control right now, but I have cube and jump that we created together. And I select it. I go back to Coherence Hub. I go to schemas and bake. And now the C#, like my code knows that there exists a way for me to call that method over the network. And what we're going to do is do this thing. So we're going to first for cubes, find all the cubes in the scene regardless of whether or not they are simulated locally or globally, right? And we're gonna go game object dot find components cube. I mean, it's still there, it's disabled. It should find it, right? And then I go for each, and I'm going, I get coherent sync reference to it. And now it doesn't know it. Now I've added coherent sync here to my imported namespaces. And now I can call something called send command on it. I can basically go send command, and I go cube and name of cube dot jump. And I define where I'm sending this command. So I can define if I'm sending it to all instances of this cube, or I'm sending it only to the authoritative, or only to the non-authoritative options. Let's just say all. Now what this will do, I don't have to call this jump anymore. Yeah.
You want to find all the cubes in the Z, because I think you have a small G, right? You're just looking at the performance. So game object.
Oh yeah, sorry. Thanks. That's a big typo. Big game objects of type. This will work. Thank you. This saved us some time. Thank you, Ivar. All right. And now let's do this. We have baked, right? We have baked. We have uploaded, and we will build. All right. And now we have this. We have this guy. We have this guy. Let's create a new room like this, and we'll create a cube here. And we will join this room. I press X here, and it doesn't work. Yeah, I think game objects of type didn't give me the cube, but I can definitely do something else, which is game objects of type coherent sync. And then we go let's do this. Yeah. Do you know what the problem is? No, it's actually the problem is basically that what I need to do, like I have on the non-authoritative, I have no cube script anywhere on, so it's basically never getting. So if I do this, it'll work. What did you think it was?
I think like you compare this as name to instance it.
Yeah.
When you instance it, like it comes with Q clone, it is just a direct comparison.
Yeah, no, I did contains only.
Okay.
Yeah, yeah.
Yeah, I didn't see that.
Yeah.
Maybe just with a like name equals.
No, but contains should work, no?
Yeah.
Yeah. Let's do it again. Basically, we're struggling with the mechanics that have nothing to do with the engine right now. It's just me being a bit maybe nervous in front of you. I don't know what it is. Thanks. No. Yeah, we got it to jump. All right, and now let's do another thing. Let's do the dreaded WebGL build. I'll switch my platform to WebGL. It's gonna be fine, Sandeep. Don't worry. Yeah. So I switched to. So I went in my project in the Coherence website. I went to share build, and there you have to enable this. You get your own public page where you can just share builds. You can upload WebGL, you can upload Windows, Linux, Mac, and you just upload the builds from within the editor. And then you can just share your link, and people can both download or just play the WebGL one. And now let's do this. Let's go to build and wildlife. Let's go builds WebGL. Oh, I have to do WebGL again here. Okay. Now let's wait and hope for the best. It's gonna be fast. But how do you find it so far? Is it confusing? Is it a lot of information? Yeah, I just want to give you a quick overview so you see you know what you're dealing with, like especially the first steps when you're prototyping something or doing, you know, in a game jam you don't care if somebody's gonna cheat in your game, right? There you can just use client-side authority. You just put things they're simulated wherever they are.
Is it possible to like transfer ownership of an entity between clients?
Yeah, and then you can do you know, the cube. I would just go what I did here. Let me show you. Oh, I hope it doesn't save. So here I would just go cube. Request authority. If I did this, request authority, it would come to me when I press X. And then the other person would have to send messages to do it. And it's very quick. It's asynchronous, but it's, you just, you know, if there's a cube and you have a character that's walking around and picking up the cube, you probably just want to request authority of it first, then pick it up, then you're carrying it. And also you can put the cube in the hierarchy of your character. So with coherence, you can do like, you have one cube and you put another cube in its hierarchy and a third cube in its hierarchy, and the hierarchy will be reflected on the server. Suddenly, when you put it in, like as a child, the child cube will be simulated in local space. So you have all this automation with what you can do with parenting and stuff like that.
Service is it player host? They can host?
Yeah, player can also host.
Does it solve like the forwarding stuff?
There's a replication server, so you don't need it. So using the replication server, which we have, which is running in the cloud, it's already a relay.
So it's in the cloud?
Yeah. So it's already a relay, and we also have like solutions for like net punch through and stuff like that, but they're not very focused on right now at Coherence. But it's kind of like in our roadmap to do those things. Yeah. Local replication server, like the server that when I went to servers and run rooms, then it just starts a local server you use to connect to during development and stuff.
On the online.
Yeah, exactly. And then you just use the online one. Yeah. This is gonna be done quickly, I think. But yeah, the parenting, then Coherence has stuff like you can define what level of detail something is synchronized at different distances from the observer. So you can go, you go into the optimize window and you say, at the close distance, I need all 32 bits with no compression of position, for instance. It's an ant walking around. I want to see every, millimeter of movement. But then the ant moves very far away. Now I don't care. I can, use just 8 bits per vector component or something to synchronize its movement. And this saves me a lot of bandwidth, potentially. Then I can also use live queries. You saw the live query that I added to the scene. I can have multiple of them, and they're cubes that are basically telling you what part of the scene you're interested in.
We have a question live.
Okay.
Enrico is asking, how can I save the position and rotation of cubes persistently? Okay.
In order to do that, you in the cube coherent sync object, you have this drop down that tells you what is the lifetime of the cube, and by default it's set to session based, and if you set that to persistent, this cube will remain. So the cube that we drag and dropped into the scene, and then everybody disconnected, next time we reconnect, that cube will still be there, and somebody can request authority or adopt it. Basically. So now we have a WebGL built. We can go to Coherence Hub and go to Coherence Cloud. And here we have this share build section. I select WebGL. I go browse and select this folder and just go begin upload. And this now uploaded it to the cloud. And now I have this link in this build sharing window. Did I click? Or maybe Chrome is better for this. All right. And I have this, I'm using some weird shaders here. Don't worry about that. Web user, let's join. And I'm in the room here, and I should be able to join with the other client. See, now I have a WebGL build in the browser, which unfortunately, because of the rendering pipeline I'm using, is crapping out with the version of Unity I'm using, which is the artifacts you're seeing. But in general, it should work fine. I have other demos that we can look at later. I have no idea. It's like the default thing I got from the asset that it was. But it's a specific version of Unity. It's 2022 1.11, which might be a bit advanced. So I usually work with 2021 3 or up, but 2021 is more reliable in my experience when it comes to that. All right. Any other questions? 2021 3, I think we decided, because we were supporting old ones, but then there's so much pain, and now it's less pain, but not little pain. All right. But maybe the rest of the questions will come when we actually start. What do you think? Yeah? All right. Thank you so much. All right.
One last one from the stream. How would you go about the following? The player plants a seed that will grow into a tree. The player logs out, and in the meantime, the tree grows.
Oh, that's a good question. I would use a persistent object. And that's, you remember last week we were talking about this exact option, right? And I would save in the persistent data of the object, I would save the time at which the last action was done, and also the current state. And then every time you log on, and also during the simulation of this object, I would just, based on the time difference, I would advance the state of the tree. Which is, so even if the tree, nobody is simulating the tree because we all disconnected and we don't have a dedicated server, the tree's information will still be there. So it will say, oh, it was started 2 days ago. We know that it grows 1 step every hour, right? So 2 days ago was maybe 48 hours ago. So I know when I next see it, I have to grow it for 48 steps. And then if I wait and look at the tree, it will just be checking, my script can be checking the time and the time difference. Then it's like, oh, 49 steps, 50 steps, and so forth.
Yeah, which saves you the cost of having a simulator.
Yeah, I mean, you could always, like, you could run a dedicated simulator and make the tree be this alive thing in the cloud also, but I would reserve that for maybe zombies, not so much trees. All right. Anything else that you found in Discord?
It was on YouTube, actually.
Okay.
No, we're good for now.
Okay, thank you for the question. Very good question. All right, thank you, and happy jamming. And yay. And just to, like, we have a Discord channel. Pat and Ciro can tell you more about that. We have channels in our Discord that are, if you need additional channels or something, talk to us. We can set those up. And yeah, just enjoy and let us know. We'll be here jamming with you. All right? Sweet. Let's do it.